right in. We have a lot to cover today because I hope I get to do it to finish 11.2 today. So we are looking at series. And so let's jump right in. And this is a list of essentially what section 11.2 deals with. We're going to start doing just a couple of questions. Questions 1 and 2 in homework are good examples of this. Where the reason I'm pausing here is I'm trying to get myself set up and I don't multitask well. There we go. I think that's us going. Come on, load up. Is this? So we'll be doing a couple of questions on how do you find the limit of a series when you're told the formula for the partial sum? So essentially a limit of a series is just another way of saying what does a series add up to? Because a series is made up of an infinite number of things added. So I guess if I was being technical, all series are a limit of something, right, if they exist. And then we're going to introduce you to different strategies, tests, techniques that you can use on certain types of series, right? Guys that look like this. We're going to look at one called the divergence test, which is a pretty simple test. It's a very powerful test, but it has one big handicap. Do a few of these guys, which are called telescoping series. These are very interesting, and we can look at them and we can show you how they, if they do converge, we can tell you what that series converges to, what it adds up to. Not only can we tell that it converges, we can even tell you what it converges to, which is quite unusual for many series, but for that particular one, it's doable. And then we're going to look at one called the geometric series. Do you remember the geometric sequence? You know, you start with a number, multiply, multiply, multiply. Well, a geometric series is just what you get when you add up a geometric sequence, right? So you take a geometric sequence, if you added them all up, we call them geometric series, and we'll look at them. I'm going to look at another very special series, got a niche market, you won't see a lot of them, that's why there's only 2, called the harmonic series. And then we're going to finish off with some applications. So, as I say, a lot to cover today. So, without further ado, let's start with number 1. If someone gives you a formula for the partial sum, suppose they give you this formula. I'm going to mute everybody, just so we can reduce on the background sound. There we go. So remember to hit the space bar when you want the answer. So suppose we get a partial sum formula and it looks like that. If you want to find out what the series is, right? So imagine the series is this guy here. They're not even telling you who EN is because they don't need to. What they're telling you is what its partial sums add up to. If I call this guy S, then S will be the limit of this fella when it tends to infinity. So you're going to have to deal with some weird looking functions. So this one I'm going to do through brute force. I'm basically just going to make n infinite. Now I know if you take a number and you raise it to the power of infinity, the suspicion is that that will become infinitely big. But that's only true half the time. Would you agree a number that's less than 1, if you raise it to the power of infinity, won't it basically disappear to 0? So what we've really got here is 2 take away 4 lots of nothing. In this case, the answer is 2. If the partial sum, let's pretend the partial sum was actually similar, but one big difference. It was 2 take away 4, 1.3 to the power of n. Wouldn't any number that's bigger than 1, if you raise it to the power of infinity, wouldn't that actually get you infinity? And it doesn't really matter what you do after that. Would you agree that the answer is what we use the catch-all phrase, it diverges. That particular one would technically diverge to negative infinity, but we normally don't care about that bit. We just say diverges and call it quits. Are we comfortable with how you could find what a series converges to? if I just tell you the formula for its partial sums. Essentially, all you do is find the limit of that. If it's a number, that's what its sum is, right? That's what it converges to. Now, one more just for fun and giggles. You're going to solve all these the same way. Suppose that was the formula for the partial sum, right? And you want to find out if it converges and what it converges to. Well, you would find that, right? And we did things like this a way back in Calc 1, right? You remember doing limits in Calc 1. What method would you use to find this limit? And brute force is not one of them because you end up with infinity on the top and infinity on the bottom. So what technique? There's actually two methods that would work. Either one will do.
Is one of them L'Hopital rule, right?
Yeah. Now, if you do L'Hopital, put a little L to tell people that's what I've just done. That guy gets you 8n, and this guy gets you 6n, but don't the n's cancel? So the answer would be 4/3. Right, so that one does converge, and it converges to 4/3. What was the other method? That one works fine, but what would the other method be?
Divide by 2n.
More than 2n, but definitely divide by. What would you divide? Yeah, divide the top and bottom by n squared. So you'd get 4 minus 1 over n squared and 3 plus 1 over n squared. Then you can do the brute force thing, and 4's left in the top and 3's left in the bottom. So the answer is 4/3. Doesn't really matter what method you use to get these answers. And in fact, the way I'm looking at the question, you don't even need to prove they converge. They only want to know what they converge to. So you already know that they're going to converge. You have to be careful that if you are doing this in homework, you can cut quite a few corners because there's lots of questions. I realize that. But if you're doing it in a test situation, I really do need to see, what you're doing. You can't just say, oh yeah, 4/3, because there are other ways to get that answer. Couldn't you simply just put in 1,000,000 for n and realize that the answer's about 4/3? Or I put in 1,000,000 here and realize the answer's probably 2. You could use that technique to check your answer, but not to replace it. So I'm crossing it off my list. Maybe I shouldn't. Are we good? If I tell you Sn, do you think you can tell me what its limit is? It's really Calc 1, L'Hopital, divide top and bottom, or brute force, the usual methods. Right, now we're going to go on to number 2. It's called the divergence test. It's very helpful, very nice test. It's pretty straightforward, but it has one major drawback. So let's tell you what it is. For any series, sigma n equals 1 to infinity an, right? So you don't even know what its formula is. For any series, if the limit as n tends to infinity of the individual terms, in other words, if that thing there, if its limit as n tends to infinity is equal to a number L, right? Now, where L is anything you like except 0. So if L is a half, if L is 1,000,000, if L is infinity, if L is -22, any situation except that, right? You can't be 0. You can make the conclusion that the series will converge. You won't be able to tell me what it converges to, it's not that clever, but that the series will converge. And that's called the I'm saying converge, darn it, space. The series diverges, right? What's the big problem? L equals 0. In other words, the limit of this is very, very often 0. And if it's 0, the test is inconclusive. What that means, we don't know. It might converge, it might diverge, right? So it's only kind of good on half the answers, right? It'll tell you half the time what's going on, and the other half of the time you're probably going to get a limit of 0. And then when that happens, it's inconclusive. So simply what you're going to do to use the divergence test, and here's a bunch of questions 3 to 8 that are going to be using that test, is find the limit of that individual thing. If the answer's a half, it diverges. If the answer's 42, it diverges. And if it's infinity, it definitely diverges. But if the answer is 0, inconclusive. You don't know. And that's a problem, right? You would like a test to tell you everything, not just tell you the bad guys, right? The divergers. So let me pick somebody. What's it? 3, 4, 5, 6. Here's our first one. The limit. Oh, first I should really start at the beginning. The guy that you're going to be doing, this guy, happens to have an an equal to 2n over 4n plus 1. And so we just find the limit as n tends to infinity of this guy. And if they wanted to write the sequence out in full, they would probably write it like that. Right? You see it? 1, then 2, then 3. That guy there. A lot of people, including me, thank goodness, can look at that and tell you what the limit is without really too much work. Can anybody just look at that fraction and tell me what the limit is going to be?
1/2.
It's going to be 1/2. Essentially, isn't it 2 over 4, right? Technically, it's L'Hopital. So stick a little L in the top just to prove everybody you know what you're doing, right? You're proving it. And the answer is 1/2. Oh, that's bad news. Isn't a limit of 1/2, which is a number, means that the series diverges, right? If you've got a number and that number's not 0, the series diverges. So there's our first answer. The series, this one, diverges. Are we good? Try another one. Jump to this one. What question is this? Is a version of question 4. Suppose I have a series that looks like this. And I'm going to use the divergence test on it, which means I'm going to find out what this does. And if this is a number, it diverges. And if this is 0, then I don't know what's going on. It's inconclusive. Okay, I need to know a method to find this limit. You don't need to tell me what the answer is, but what would be the best method to figure out that guy? Any suggestions?
Take the derivative.
Oh, so you want to do a L'Hopital thing?
Yeah.
Yeah. If you a lot of times that's going to be the right way to go, but the reason why it's not the right way to go here, aren't you going to have 0 on the top and probably 0 on the bottom when you're finished, and 0 on the top and the bottom kind of screws up your problem, right? I'm going to rewrite it a slightly different way. Isn't e to the negative n actually the same thing as that? Right, does that give you a clue about the method I'm going to use? I call it brute force. Basically, just put infinity in and see what we get. So we're going to get 1, 2 plus 1 over e to the infinity. You probably don't need all these lines, but here goes. Isn't 1 over e to the infinity 1 over infinity? And 1 over infinity is 0. So that's essentially 0. And so the answer is 1/2. And guess what? It diverges. If that guy is not 0, it diverges, right? let's try this fella. Okay, want to find out if that series diverges or converges. That's all you need to do here, right? Well, diverges technically. Diverges or inconclusive are the two answers you're going to get. Right, for this fraction, what technique would I use to find its limit? E to the 2n on the top, n squared on the bottom. What would be a good method?
Relative rate of increase.
You know, I didn't think about that, but yes, that would work. Wouldn't e to the 2n murder n squared? In fact, can't you make the conclusion then that the answer is infinity? In which case, the conclusion after that then isn't it, it diverges. But now that someone gave me a better answer than mine, does anybody want to tell me the second best answer for how to find out what that limit is? I feel like there should be one of those quiz clocks going do, you know, and there's going to be a bell at the end, but we don't have time for that. Last chance. Anybody want to have a shot at it? What could I do?
L'Hopital's.
Yeah, you have to do it twice, but eventually you'll get the answer and it's infinity. So the divergence test is, it does one job. It finds out when things diverges. It never tells you whether it converges, right? It only tells you if it diverges. And we seem to have been quite lucky here. Everyone that I've picked so far has worked, right? In other words, I mean, it's diverged. But, you know, there's going to be a question where the limit is 0. And when that's 0, you'll stick in the box inconclusive, right? That's basically what you would do. Are we good on the divergence test, or do you want to see some more versions of that guy?
Hey, hi. I had a question. So, on that the last example we just did, what was the first way we solved it again?
Oh, the first way we did was the relative rate of change. So there's, if you look at the notes, there's a big list of things, but what you'll find is that e to the 2n is up here and n squared is here. And that means this gets to infinity bigger and quicker than this does. And then what you can do then is, well, whatever one wins tells you the answer. If the one that wins on the top, it's infinity. If the e to the 2n in the bottom, wouldn't the answer be essentially 1 over infinity? It would get you 0, right? That would be the alternate, right? So if I turn them upside down, you would get that.
Thank you.
Are we good? Right. So I'm going to show you one more situation that is still the divergence test, but doesn't look like. We're being asked, does this converge or does it diverge? Well, the problem with this fella is, right, we don't know who the individual ANs are, right? You know, the pieces that are going to be added together. And so we've got a little sub job to do, right? And this is going to be, eventually it's going to be written like that with an AN in here, right? And that's what it is eventually going to be written like. But I need to know AN. So we've done a few of these, probably not as many as I'd like, but we're going to do quite a few. First thing that I notice is it's a fraction, so that's not much of a giveaway. The first number is a 1 on top. The second term has a 2 on top. The fourth term has 4 on top. What would the nth term have on top? Don't overthink it. 1 gets you 1, 3 gets you 3. What will n get you?
N over n plus 1.
Oh, you got both sides. Agreed. n over n plus 1. So I now know that that is our go-to guy. So if you wanted to write that entire sequence down, right, forever, that would be it. Now that I've got that, can I do the divergence test, which is you find the limit of the individual terms. And if they're not equal to 0, then you have a divergence. Well, we could do that one, L'Hopital. In fact, a lot of the questions, isn't the math so far anyway, the limit's been pretty straightforward. You almost do half of them in your head. Now, since the limit of that is not 0, that means the series diverges. So if the limit of the individual terms is a number that's not 0, the series diverges. Right? That's essentially the divergence test in a nutshell. Right? If the limit of the individual terms is a number that's not 0, then the series diverges. If the limit is 0, then you're going to say inconclusive, right? Actually, chapter 11, more than half of chapter 11 is dealing with one job, finding out if a series converges or not. There's going to be, I think, off the top of my head, there's going to be something like 9 different tests, right? Ways you can answer that question. There's your first one, divergence test. That doesn't count, right? That's your first one, right? And we've hopefully finished that. Do you feel good about that? Right? If I give you a series and you use the divergence test on it, you'll be able to say, yep, it diverges, or yeah, inconclusive, I don't know. So the next fella is called a telescoping series. That's number 3. And telescoping series have a very, very specific look to them. I'll show you by picking, actually the first one's a good example of it. You have n equals 1 to infinity, and you're going to have something take away something. That's what they look like. An A take away B kind of look. And both pieces are very similar looking algebraically. So here's that guy and that guy. Would you agree they're very similar looking, right? So how do you solve these ones, right? Well, they're really just got their own specific method, right? So what we do here is we write down the first term, right? So when n equals 1, you get e squared, and when n equals 1, you get take away e to the 1. That's the first term. Plus, if you plug in 2, you get e to the 1, take away e to the 2/3. You plug in the next one, you get e to the 2/3, take away e to the 2/4, right? And you keep on going, right? And then you essentially stop at some random unspecified location called that. And what we've actually done here is write down what the partial sum Sn would be. Would you agree it would be all these terms and it would finish on that one? So S10 would have a 10 here and here. So that's like your first step. Write down the first 2, 3, 4, whatever it takes till you're comfortable. Now, one of the things about a telescoping series, and I think it gets its name, do you know those old telescopes that pirates use, right, that they watch the sea? Didn't they all crunch into a little thing that size, right? This series crunches into a very small series. Let's see what happens. Did you notice that that negative e to the 1 gets killed off by that positive one? Did you notice that that guy got killed off by that guy? Now, can you trust me that that guy would be killed off by somebody that came later, and that guy in turn would be killed off? Essentially, wouldn't everybody in the middle die? In fact, that guy there would be killed off by somebody over here. So what is left here is an e squared, the first term, and this guy over here. So if you added up the first n terms of this series, there you go. Do you see what we've now generated is a formula for the partial sum? Right? Because only the first term lives. Everybody in the middle gets killed off by somebody that comes later. And then the last term survives, right? So if one of these works, one of these will work, right? So what I'm going to do now is I'm going to say, if I know what the formula for the partial sum is, can I find its limit as n goes to infinity? Let's see what we get. I'm going to do the limit as n tends to infinity of e squared, take away e to the 2 over n plus 1. So far, so good. Right, I want to find the answer to this limit, e squared, take away e to the power of 2 over n plus 1. Can I just do a brute force on this one? Just make n infinite. So what am I going to get? I'm going to get e squared, take away e. Well, 1 plus infinity is still infinity. So won't that be e squared, take away e to the 0? Wait a minute, e to the 0 is a number. So in a telescoping series, I can tell you two things. First thing is, I can tell you that the series converges. And the reason I know that it converges is because the limit of its partial sums is a number, any number. Not only that, can't I tell you what the series converges to? Isn't the series equal to e squared minus 1? So the divergence test never told you things like that, right? But a telescoping series does. It's pretty rare for things to do that. There are a couple of ones, the geometric's another one, where not only do you get to tell if it's going to converge or diverge, when they converge, you even know what it is. So what would a diverging one look like? Can you imagine a different world, a different story where this thing was infinite or that thing was infinite, but most likely this one was? When you have e squared take away infinity, answer some version of infinity. Well, if the partial sum, goes to infinity, doesn't the series diverge? Because it adds up to infinite, and that's how you would know. So if that is a number, any term that's a number, the series converges, and the series is equal to that. So that means this guy up here converges, or is equal to, if you prefer, e squared minus 1. Cool? Called a telescoping series. Here's one. N equals 1 to infinity. 1 over the cube root of n, take away 1 over the cube root of n plus 1. Okay. I'm going to plug in 1, and you get 1 over the cube root of 1, take away 1 over the cube root of 2. And then plug in 2, and what do I get? 1 over the cube root of 2, take away 1 over cube root of 3, put in 1 more. You get 1 over the cube root, not a cube root, cube root of 3, take away 1 over the cube root of 4, and then dot, 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 dot. And if we stopped at the nth term, which is this guy here, you'd stop at 1 over cube root of n, take away 1 over cube root of n plus 1. Are you comfortable about the setup? I'm writing down the first 3 numbers and then just say dot, dot, dot and finish on the nth number. And the nth number is this fella. Does anybody get killed in this one? Because they better or we're in trouble. Anything you can see killed off by something that comes later? Now, tell me one.
The 1 over negative 3, the negative 1 over 3 cube root 2.
Yep, great. Would you agree that one gets killed off by that one? Can you pretend that you can see it? Could you imagine this one would get killed off by somebody here? And at the end term, here's a little trick. If the first one lives, so does the last one, right? So if the first one is the one that lives, so does the last one. So I'll kill that one off with something that goes there. So it means that the formula for the partial sum is just 1 over the cube root of 1, take away 1 over the cube root of n plus 1. And that's basically 1 then. And so now I find the limit as n tends to infinity of the partial sum, which in this case becomes this fella. I'm just returning that into a simpler version. Would you agree brute force works really well with this? You don't need to do anything too clever. You can just plug infinity in. Let's see what we get then. We get 1 take away essentially the cube root of infinity, which is infinite, and 1 over infinite 0. So you get 1. And that means that we know that the series converges. And not only that, as an added bonus, we know that the series adds up to 1 or converges to 1. Cool. So let's make it a little bit harder for you. Just a little. Okay. Let's do that one. Doesn't look particularly scary, but it has a little kink in it that you have to be aware of. It's 2 over n minus 2 over n plus 1. Okay. So I'll start with this then. And you plug in 1, you get 2 over 1, take away 2/3. I can live with that. You plug in 2, you get 2 over 2, take away 2/4. You plug in the next one, you get 2/3, take away 2/5. I'm going to put an extra one in. You get 2/4, take away 2/5. I guess I should simplify some of them, but I don't think it's helpful. It's probably easier just leaving them the way they are. Oh, and then you finish, as you would expect, with the last term, right? The nth term. Agreed? Now, when you look at this particular setup, that doesn't get killed, right? This negative 2/3, won't it eventually get killed by this guy? Does 2 over 2 ever get killed? Is there anything that's going to come after it that's 2 over 2, right? Minus 2 over 2. No. So there's 2 terms that make it out alive. Now, does this one get killed? Yeah, it gets killed by that guy. Does, that should be 2/6 there. Does that one get killed? Can you trust me? Yeah, it probably get killed by somebody there. Does this one get killed? Yes. So what we have here is that there are 2 numbers left alive. That one and that one. Now, what about at the other end? If 2 guys are left alive at the front, shouldn't they be compensated, by 2 guys at the end? And it's not these 2 guys. It definitely is, one of them is this guy, right? Have you noticed that these 2 numbers are in the front, right? So the ones in the front live, at the end, the ones at the end live, right? So that's that one. So you might say, well, if it's not that guy, take away that guy that's left, who is the other one? Well, you have to kind of imagine what the previous term would have been. And it's okay when it's 5, the previous term's 4, right? It's a little bit trickier when it's this. If this guy is 2 over n, won't the previous one be 2 over n minus 1? Are you happy about that? And if this is 2 over n plus 1, won't the previous guy be 2 over n plus 1? And so the guys that get killed are them, and the 2 guys that make it out alive are that. Would you agree, although that might not make a big difference in the end, the big scheme of things, that's the correct answer, agreed? In fact, if you wanted to, not that I do, but if you wanted to know what the first 100 terms are, wouldn't you just do that plus that minus 2 over 101 minus 2 over 102, right? You could get the exact answer to any partial sum. but we're just interested in the entire series. So we're going to find that guy. Oops. Would you agree that that's pretty easy to do? It might look big, but it's pretty easy to do. And again, I think brute force works perfectly fine. Would you agree? Just make n infinite. So let's see what the limits are. That's 2, that's 1, that's 2 over infinity, and that's another 2 over infinity. Both of them are 0, so you get the answer 3. So this one, the series converges, and that the series is equal to 3. So far, so good. Let's show you one diverging now, because not all telescoping series, that's what we call the ones that look like that, not all of them actually do converge. So here is one. This guy is a version, question 11. It's 9, the natural log of n over n plus 1. Now, it might not look like a telescoping series, but it's going to become one. If you have a log of two things divided, can't you write it as log of the first guy, take away the log of the second guy? You comfortable with that? The log of two things divided is the log of the top thing, subtract the log of the bottom, right? It's one of the laws of logs. Now, I have a telescoping series. Isn't it something, take away something, and they look like each other? So here goes. If you plug in 1, you get 9 times the log of 1, take away 9 times the log of 2. And then if you plug in 2, you get 9 times the log of 2, take away the log of 3. Actually, yeah. I can either bring the 9 outside or bring it inside. I've kind of done both here, so figure it out yourself. Bring out the 9s or stick them back in. Now, if I keep going, I would eventually get this fella here at the end. Okay, let's see what gets killed. Won't that guy get killed by him? Won't that guy get killed by him? Won't that guy get killed by someone else? And that means that we're only going to have one term left alive at the beginning. And if the guy at the beginning lives, doesn't that mean the guy at the end lives? So I have, that's what the partial sum is, right? The first guy makes it out alive, the last term here out of the 2. Now I'm going to find out what the limit as n tends to infinity of the partial sum is. Very often this is going to be the easiest bit of the question, because a lot of the time finding the limit is going to be quite trivial. Would you agree? Brute force yet again. Right, just plug in infinity and see what you get. Right, so what have we got? 9 times log 1 is actually 9 times 0. Take away 9 times the log of infinity. Well, the log of infinity is infinity, and if you multiply it by -9, you just get negative infinity. And 0 take away negative infinity is negative infinity. So we will say that the series diverges. And that's the end of the line. If it diverges, you're done. There's nothing else you can say. Are we okay with, so far, are we okay with the telescoping series and how you find out whether they converge or not by doing this technique of writing down the first 3 or 4 terms and then what the last term or terms could be? and then a whole load of things getting killed, and you're going to be left with typically 2 or 4 terms. That's the most common, right? A lot of the time it's 2, but sometimes it's 4. And then you just figure out what the limit is, and a lot of those times, isn't it going to be just a brute force? And boom, you're finished. So what am I keeping to the end? I am keeping a stinker. And I'm telling you right now, a stinker to the end. And it's question 12, or at least a version of it. That does not look like a telescoping series, does it? Shouldn't it be somebody take away somebody, right? That's what they look like, right? A take away B. That's a single fraction. So the first thing I'm going to do is I'm going to make it look like the way it should look. And that brings us to our first problem. I want to split a fraction into its 2 pieces. These 2 pieces, oops, let's make it say 3 there, are called partial fractions. Can you remember that term from integration? It was a special situation where you wanted to integrate an ugly fraction, and the best way to do it was to break it into 2 pieces called their partial fractions. And there's a number A here and there's a number B here. These will be numbers. And I can tell you right now, technically you should put a plus there, but it's going to be this guy take away that guy. I know it because it's a telescoping series and that's what they look like. How do you find the coefficients A and B? Can anybody remember?
You multiply both sides by their denominator first.
That's definitely a method that is taught.
And
it works totally fine.
Then you find the A and B by plugging in what number that just make the n inside become 0.
Okay. I would call that method, if it's one I think I'm hearing, the general algebraic method. Anybody get me for Calc 2?
Cover-up method.
Say that again, Ismail.
The cover-up method.
Yeah. Ismail, you have seen the cover-up method. A lot of people obviously haven't, so I'm about to show them it. Would you agree it's a much more efficient method than all the other stuff that you would have to do if you wanted to do it the long way?
Definitely.
Yeah. Would you also agree it's magic? There's no reason why it should work. Right? But that's okay, right? There is a reason why it works, but you don't need to know it. So I'm going to show you the cover-up method. And if you don't know the cover-up method, you might like this. If you do not like this method that I'm about to show you, which could easily be true, then all I want you to do is do whatever method that you've used in the past from Calc 2. So here goes the cover-up method. I want to know this number A, right? I want to know that guy. Right? N in the bottom. Go over here and cover up the N. You see I've got a little baby fraction there. In this fraction, replace the N by whatever made this guy 0, which is kind of silly because it's 0. And so what do I have? I have 27 over 0 plus 3. I have 27 over 3, and the answer is 9. That's how I got it. Now let's do the second guy, the N plus 3 guy, right? This one. Cover up N plus 3. What value of N do you need to make N plus 3 0? Well, you need to make it -3 to do that. Make this guy -3 as well. 27 on the top, -3 on the bottom, -9. And we've now done the cover-up method, right? That is, well, if I speed that up, that would have taken about 1 minute or less. If you did the general algebraic method, which is what I think someone was describing to me earlier, I doubt you could do it so quickly. Do you like this trick? Right, if you don't like it, cool with that too. Right. So back to the story. We are being asked to find that guy, right? Well, I'm now splitting it by rewriting it in its version. Would you agree that that is a telescoping series? So let's just do the telescoping thing. If you plug in 1, you get that guy. If you plug in n equals 2, you get that guy. If you plug in n equals 3, you get that guy. If you plug in n equals 4, you get that guy forever. And then you would finish with the last guy, which is this fella. Okay, this one's going to have a lot of guys who make it out alive. Right. Would you agree that 9 over 1 is never going to get killed because none of the terms after it are even close to it? So that one lives. I'll put a little circle around the ones that live. That one lives. Well, 9/4 die. Well, this one die. Yeah. This one gets killed off here. Right. Well, 9/2 make it. Yeah. Although you can't see it, can you trust me that this guy gets killed off by somebody that would go here? You have to keep on imagining. So that one gets killed by somebody who's over here. Can I tell you that this one's going to live and that one's going to get killed off and that one and everybody's going to die. And so what we now have is a 9 over 1, a 9 over 2, and a 9 over 3. And the ones that made it out alive were at the beginning, right? So doesn't that mean the ones at the end, right? This one here, for instance, will make it. Won't the next one come from here? What would that term be in terms of n? This one is 9 over n plus 3. What will that one be?
N minus 1.
Well, that one that's here would be n minus 1, but what would the other one be? That one here would be n over n minus 1, but what would this one become? This is n plus 3. What would the one just before n plus 3 be? Any suggestions?
N plus, 9 over n plus 2.
Yeah. And once you've seen a couple, can you kind of predict that's going to be the third one? Right. So if you wanted to know the precise version, you'd have 3 guys at the front that lived and 3 guys at the end. That one, and one that would go there. And this fella can now do the limit as n tends to infinity. Well, since I've already written up, I don't want to write it again. So I'm going to get 9 plus 9/2 plus 3. Brute force, 9 over infinity, which is 0. 9 over infinity, which is another 0. And 9 over infinity, which is yet another 0. So essentially, that's the answer, which is what, 12, 4, 16.5. So that's 33/2. So the series converges. And it's equal to 33/2. That one had a lot of problems. Didn't you have to turn it into its partial fractions? And then you had the horrible thing that there were actually 3 terms at the front and therefore 3 terms at the end. And it's quite easy, I almost did it, to think that there might only be 2, right? You might just say, oh, well, it's the first couple that live and the rest will die somewhere. In fact, it's the first 3 that live and then the rest die. Have you noticed that my version of mathematics is very violent? Things get killed everywhere, don't they? It's like carnage. I think that's probably just part of my culture. Scottish people in general are quite violent. So I suspect it's just, I think it's that. That's essentially it. Okay. I hope that is enough for us to tick off telescoping series. Do you feel comfortable about that? Wish I had more time, but I don't. So I'm now going to move on to the 4th one, in the list, which is a biggie. It's called the geometric series, and we're going to use what's called the geometric series test. So, what does a geometric series look like? They have a particular shape. This is essentially what they look like. A r to the n minus 1. Now, that is a number times this guy n minus 1. Remember the AR n minus 1 thing that we did in sequences, right? That's what they look like. Now, they have lots and lots of different flavors. It doesn't make them any different. They might be 4 times a half to the power of n minus 1. Well, that would be a nice straightforward one. But you could also get things like n equals 1 to infinity of 7 times 3 over 2 to the n plus 1, right? They could look like that as well. So that is just one version of them. What makes you a geometric series is there's going to be a number, like 2, 4, 42, could be a minus 4, whatever, followed by something raised to the power of n minus 1, n plus 2, that type of thing, right? So these are all geometric series, okay? So what is the geometric series test? How does it say this one converges, which by the way it does, but this one diverges, which it does? It's a very simple test. It uses R, right? And R is the common ratio. Remember the number you multiply 1 by to get to the next number, you multiply it by that to get the next number and the next number, right? That's the guy that's called R. So when you have a geometric series in front of you, for instance, this one, R would be a half. If you were doing this one, wouldn't R be 3 halves? Agreed? So far, so good. Now, so what's the test? Here it is. If the absolute value of R is less than 1, the series converges. And if the absolute value of R is greater than or equal to 1, the series diverges. Now that makes this a very powerful test, because if you're a geometric series, aren't you guaranteed to converge or diverge, right? Because isn't your R value going to be one of these two, right? It's either going to be less than 1. Oh, and by the way, the reason they have absolute values is, couldn't this be negative a half to n minus 1? Right, or minus 1 to the n plus 1 outside, right? You could have, you know, that little alternating thing. So that could be negative and so could that, but when you make it the absolute value, the test still works. Now, that means right away, since this one has an R value of a half, can't we just say that it converges? Would you agree? I didn't need to do any limits or anything. Can't you just look and say the R value is a half, it converges? Right. Now, in the math world, we have to be a little bit more specific. So what you would say is something like this: R equals a half, comma. The absolute value of R is less than 1, which it clearly is, comma. So the series converges, right? You just try and say it. Now, what do you think is going to happen to this second one, where the R, the common ratio, is 3 halves? Will that converge or will that diverge?
That one diverge, I assume.
It does. And in a test situation, you would say that guy is true, that guy is bigger than 1, so it diverges, right? So you basically tell me why you know it diverges, because couldn't you just go with a coin? Heads, okay, it converges, right? Tails, okay, it diverges. Couldn't you just say that? There's no indication. If I write this little line, doesn't it at least lead me to say, he knows what R is. He knows that's important. He knows that the absolute value of it is less than this special number. And that leads him or led her to the conclusion that it converges. Now, that is pretty good test, isn't it? It's very powerful. You're either going to work, converges, or you're not going to work, you've diverges. But that's not finished.
I had a question.
Yes.
So it says if R is greater than or equal to 1, it diverges.
Yes.
So if it's equal to 1, if R is
It's-
equal to 1, why would it diverge?
Oh, let's do one. I'll do it over here. Here's a series. 4 times 1 to the power of n minus 1. Okay. Agree R is 1 in this case. So if you plug in 1, you get 4 times 1 to the 0. And then you get 4 times 1 to the 1. And then you get 4 times 1 squared. And then you get 4 times 1 cubed. Aren't you essentially adding up an infinite number of 1s, and therefore you diverge because your answer's infinite?
Yeah, that makes sense now.
Okay. Now, when a series converges, so when a series converges, we know what it converges to, because there's a formula for it. It's equal to A over 1 minus R. And to remind you, A is the first term, right? The first number, right? The first guy. And R, we know who he is, right? R is the common measure. So this one converges, doesn't it? Agreed? So if I take this one, because I know it converges, we've already proved that. I already know what R is, right? It's a half. If you plug n equals 1 in here, don't you get 4 times a half to the power of 0, which is 4 times 1, because anything to the power of 0 is considered 1. And so won't the first term be 4? And so that is A. You see how I got it? Now, you put them together. The sum then is A over 1 minus R, right? So that guy. That's going to be 4 over 1 take away a half. That's going to be 4 over a half. And that's going to be 8. So far, so good. Can you remember the poor little frog story trying to jump into the well? Remember that one? Just remember, right? Looked like that. The distance to there and there was 2 meters, and the frog went 1, then it went a half, then it went a quarter, right? And it kept on jumping, right? That guy. Let's see what that looks like. As a geometric series, the frog has a formula 1/2 to the n minus 1. Can you trust me? That's what the formula is, but you can check it. Put in 1 and you get a half to the 0, which is 1. You put in the next number, you get a half. You put in 2, you get a quarter. You put in 3, you get that, and so on. So this is the geometric series for the frog. If you add up all these terms, that's what it would look like. Now, in this case, isn't R a half, so it converges. So that means all these little jumps add up to something. The first term is simply just going to be 1/2 to the power of 0, which is 1, which I already knew that the first jump wasn't at 1 unit. And so since I know it converges, what do all of those add up to? So if you could sit and watch that poor frog jumping to eternity, theoretically, wouldn't the total distance be as a limit 2? So we go with it. So let's do some geometric series tests. Let's find some guys and find out if they converge. There's a whole bunch of them, 13 to 20. So I'm just randomly going to pick one. This one here, question 15. And question 15 has 10, -8, -6.4. And I just made a mistake there, so I'll start again. It's 10, take away 8, add 6.4, take away 5.12, add blah, blah, blah. Now, you're actually told that it's a geometric, so you don't need to worry about that. In fact, I don't even need to create the formula for it. Isn't the only two things I need to know is who is A and who is the common ratio R? Well, I think it's kind of obvious that A is 10. Would you agree that's the first number? Now, I think the last time someone told us a pretty cool way, or at least they expressed it in a really cool way for me. How do we find the common ratio? I know sometimes you can do it in your head, but in general, how do you find the common ratio?
Is that the second divided by the first and then check all the rest, right?
Yeah. So the second is -8 divided by that guy, and so it's -4/5. Now, technically I should check the others, but since the question tells me it's geometric, I don't need to bother checking because it is, right? But if they didn't mention that, when I checked that times that and that divided by that, they all came out as -4/5. So far, so good. Right, now, does this series, because that's technically as a whole load of things being added up, so that counts as a series, does this series converge? Well, here is the R value. The absolute value of it is 4/5. And would you agree that is less than 1? So does it not make this converge? So far, so good, converges. And so that would be the first part of your answer, it converges. Now, how about what does it add up to? Well, it's A over 1 take away R. So it's 10 over 1 take away -4/5, which is probably best done on a calculator, especially at this time of night for me. So I'm going to go 10 divided by, in brackets, a 1 add 4/5. And then just hit the math button and turn the answer into a fraction. So the answer is 59ths. So I'm glad they did it and not me. You happy about how you can use the calculator to do fractions? Well, that's it. That adds up to 59ths, right? It converges. And what does it converge to? It converges to whatever 59ths is if you want to do a decimal. Are we good so far? Suppose we give you one a little bit different looking, maybe more the way you thought they were going to look, but we give you the geometric series and it's written like this guy. Okay. We know it's a geometric, they told us, but even if they didn't tell us, doesn't it have that look that we're looking for, right? Something times a power, in this case, n-1. But don't be put off by the n-1. That's allowed to be n+1 or just n, right? It can be anything as long as it's got n in it. Would you agree that R is 0.55? And so this converges. Technically speaking, I should be doing that, right? Now, I need to know who A is. This one's going to be pretty easy to do. I could probably do it in my head, but I'm going to do it as a calculation. 25 times 1, A is going to be 25. So, yes, this converges would be part A. Part B is, what does it converge to? Well, whatever A over 1 minus R gets us. And so that's 25 over 1 take away 0.55. And that is probably best done on the calculator again. So 25 divided by 1 take away 0.55. And let's see if it becomes a nice fraction. Oh, let's use it. It's a nice fraction. So if you can, make the answer a fraction, because see if you don't, won't you get you know, 17.1287766, you know, blah, blah, blah. And it'll look really messy, and it'll only be an estimate because you have to stop somewhere, don't you? And you'll have to round off. So, you know, just hit the fraction button on your calculator, right? And see if it turns into something nice. Do you like a geometric series? Can you look at one of them and say, yeah, I could tell you whether it converges or not by finding the R value? Right? It's not really hidden, is it? I mean, it's pretty much in your face when they're written this way. It's a little bit more hidden here. Haven't you got to do the second guy divided by the first guy? But it's doable. Any questions so far about the geometric series? You feel good about them? Right. Let's put in a weird version of it. It's always good to do weird ones because they tend to cause the biggest trouble. Here's a weird one. Question 19. Now that might not look like a geometric series, but they tell me it is because it is. But it doesn't have that, you know, it doesn't look like this guy. That's the way we'd love them to be written, right? Isn't that the easiest ones to deal with, right? Because when they're written that way, you can tell. Nonetheless, it is a geometric, which means I should be able to find the R value and then the A value. The A value is the easy one. Just plug one in and see what you get. I get -7 to the power of 0 over 9 to the power of 1. You're happy about that's a 0, but this is a 1. And that is 1, because any number to the power of 0 is 1 over 9. So there's A, it's a 9. There are two different ways to find R. The first one is you eyeball it. Right? What do you think R is? And it's one of those, don't let the trees get in the way of seeing the wood, or whatever that phrase is, right? You can't see the wood for the trees, right? Just cut to the chase. What essentially would R be in that question? Just eyeball it.
Would it be -7?
-7 is in the answer. Anything else?
-7/9.
Agreed. Would you agree that that's got an n in it, and so does that? So these should be it. So basically, I don't care if that's n plus 2 and that's n minus 7. The important part is there's a -7 here and there's a 9 there, and that's what we got, right? Now, I said there's two ways to do it. Wouldn't I plug n equals 1 to get the first term, which is this? Couldn't I then put n equals 2 into this to get the second term? And then couldn't I divide the second by the first? 5 minutes later, that would pop out. So I could do it by simply just plugging in 1 and then 2 into this expression. So when you plug in 1, you get A1. When you plug in 2, you get A2, and divide the two answers and make it look pretty. Does that one converge?
Yes.
Yes. I'm not going to do it, but couldn't you find S equals A over 1 minus R, right? It's pretty standard from that point onwards. Right. Once you know these two, don't you know everything that you need to know? You know if it converges or not, and you also know what it would be. Just because they can. One of the questions looks a bit like this guy. He is a geometric series. What is R? Just eyeball it. Don't let the
The sine of
trees get in the way.
500.
Yep. Sine of 500. I mean, aren't you used to a half and 3/4 and 1.7s and things, right? But isn't that a number? And it's a number raised to power, so that's R. If you wanted to find A, which we do, don't you just plug 1 into this expression, and oh, you also get the sine of 500. So there's a geometric series where the A value and the common ratio are the same. Now, does this converge? Well, to be honest, I don't No, but I'm pretty sure I can guess. What do you think? Will this series converge?
I think so.
Yeah. I'm about to hit the button just to convince myself, but isn't a sign always going to be a number between 1 and -1? So won't R be inside the range? But for completeness sake, if you're interested in it, the sine of 500 is -0.46. So it converges. And then can't we do the A, A over 1 minus R? And your answer will be pretty boring. I think it will be sine of 500 over 1 minus the sine of 500. Don't do anything to it. That's the answer. Are we good? So I'm going to tick off my little list. That guy. Let's move on to what's called the harmonic series. And there's only 2 questions that use a harmonic series. It's a very specialized series. But it's, if things are important, they get names. Geometric series was a nice family of lots of series, but they occur in very often lots of situations, and they're pretty useful. So because of that, they get a name. This is the harmonic series. And it's very often used, one of its uses anyway, is to explain to students a preconceived idea that they have and to show it's not true. A lot of students will look at this and say, well, this guy's getting smaller and smaller and smaller and smaller forever. That series should converge, right? Their gut feeling is that if you add up lots of things, but they get smaller and smaller and smaller, right? It's going to converge. Like, remember the fog, 1 plus a half plus a quarter plus an 8, that kind of thing, right? If you write this harmonic series down, it has a very nice, simple formula. Would you agree it's just 1 over n? And here is the crux. It diverges. Does that seem reasonable? That something that gets smaller and smaller adds up to, in fact, infinity? And that's good if you can accept that. A lot of students find that hard to get their head around. They think it must be equal to something, right? 42 or whatever, right? But it's not, it's actually infinite. Now, I can't prove it to you with the math that you've got, but I'll do a pseudo proof, right? A kind of proof. If you take this particular series and you do it like this, you do 1 plus a half. If you take the next 4 fractions and you add them up, you'll get a fraction that's just a little bit bigger than a half. I'm going to call it a half plus, right? It's just a little bit more than a half. If you take the next 8 fractions, right? So that would be 1/7, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, right? If you take the next 8 fractions, they also add up to a fraction that's a little bit bigger than a half. And then the next 16 adds up to a fraction that's just a little bit bigger than a half, and the next 32 and the next 64. Now, since this is infinite, can't you keep doing that forever? So what you're going to be doing is, in fact, adding up 1 plus a half plus an infinite number of things that are a little bit bigger than a half. Well, won't that be infinite then? And that's kind of a pseudo proof of why that works. Now, what can you do with harmonic series? Well, if you recognize one, you know it diverges. So that's the trick, recognizing it when you see it. Well, when it's written like that, you can see it. Do you recognize that as belonging to the harmonic series family? Now, what makes you belong to the harmonic series family is that you should be some number, b, over n plus c, or some number b over an plus c. They all have a linear term on the bottom. The top term is just a number. It's going to be 5, it's going to be 6, it's going to be 22, and the bottom is going to be n plus 1, n plus a half, 4n plus 7, 4n take away 7. If you ever see a series that looks like this, you're in the harmonic series family. And so your answer is that it diverges. Because every single one of the series that belong to the harmonic series, all of them diverge. Every single one of them. So if you recognize it's harmonic, you can diverge. So I'm going to switch it over and show you a harmonic series. I've kind of given the show away because I've told you it's a harmonic series, but nonetheless, there you go. Can you see question 22? 1/7, 1/14, 1/21. Isn't that essentially 1 over 7n? Isn't that in the harmonic series family? It diverges. Now, the one above it is a little bit weird, but I have 5 over 9 to the n, and then I've got an add 2 over n. Isn't 2 over n in the harmonic series family? So that means it diverges. Now here's a trick, or a kind of truism. If one bit of the thing's broke, the whole thing's broke. I don't care what 5 over 9 to the n does. It can converge to 20. It can diverge to anywhere it likes. But won't it have no effect on the fact that the other bit kills it anyway? It makes it infinite. So if you see a really weird series, but you recognize one piece of it is harmonic, can't you just go right in and say diverges? And you don't need to worry about finding out what the other bits are. I mean, you can if you feel like it, but don't bother, right? Because the answer is just going to be diverge. Not a lot to the harmonic series. It's really, can I recognize one? And if I find one, it diverges. And that's the end of the story. Are we good? Okay, looks like we might make it. So, a couple of interesting little, I'm calling them applications. I don't know what else to call them. So let me return back and show you some. They're really just fun things. They're not, you know, an engineer's not going to do this, but they're kind of fun, right? Let's do repeating decimals. Right? Normally when you have a repeating decimal, isn't the usual notation just to do the little bar above the repeating digit and call it good? Our question, our problem is, I want to know what fraction makes that repeating decimal hung. And we're going to do it by using geometric series. And then after I've done that, I'm going to show you something that should make your brain explode. But let's just do this right now. I'm going to look at that in a different way. I'm going to look at the thing as if it is, which it is, a series, isn't it? Would you agree if you add all these up, won't you get that repeating decimal? Agreed? Now, it's a geometric series. And A is 0.12, right? That's the first guy. What is the common ratio? What are you multiplying? Say again?
Is that 12 over 10 to the power of something, right?
Not sure. Yeah.
Dividing by 100 each time.
Yeah, you're dividing by 100, which might be what you were getting at. I'm just going to call it 0.01. Isn't multiplying by 0.1 the same thing as dividing by 100? But you're right, it's dividing by 100. Since this is a decimal, I might as well make that a decimal. Doesn't that converge? Which you kind of know, right? It should converge. So let's see what it ends up being equal to. So I'm going to use that formula, right? Geometric series adds up to. On the top, I'm going to get 0.12. And on the bottom, I'm going to get 0.01. And then, since I want a fraction, I'm going to go here. And I'm going to go 0.12 divided by bracket 1 subtract 0.01, close the bracket and hit enter. And now I'm going to hopefully get math fraction. And the answer is 433s. Let's check it out. 4 divided by 33 equals that, right? Now, some of you might say, oh, wait a minute, I can do it even easier than that. I'm going to do 0.12121212, and I'm going to go math, and I'm going to make it a fraction. Oh, it doesn't work, does it? So you have to do it this way, right? You can't just let the calculator, oh, I'll just write in 20, you know, you can't do 20. I'll write in 12 decimals and we're good. So that's how you're going to do, how do you find a fraction that is equivalent to this repeating one? So now I'm going to blow your brain, right? I said to you, I'm going to show you something that's going to just scare you. Can you imagine the decimal 0.9 repeater? Right? Would you agree that that decimal is not the number 1? It's 0.99999, right? It's not exactly 1. Agreed? Now, if I write it down the usual way, in this case, the first guy, then the second guy, then the third guy, would you agree that in this case, A is 0.9, and won't the common ratio be just 0.1? You happy with that? And I know it converges, that was obvious. What does it converge to? Well, it converges to 0.9 over 1 take away 0.9. It converges, 0.1, sorry. It converges to 0.9 over 0.9, which is 1. Oh. I haven't done anything wrong. But evidently, 0.99 forever is 1. Now let's try and get our head around how that could possibly be true, because that isn't 1, right? It's got lots of 9s in it, right? It's not 1. So let me turn the question on its head. If you took 1 and subtracted 0.9 repeater from it, what would the answer be?
Infinitely small.
Okay.
Yeah,
0 point
0001 or 000, right?
forever?
Point
Should-
infinite
have-
0, 1.
Infinite zeros, what? Do you see the problem that infinity brings into the math world? That sometimes you'll come to a conclusion that you really can't get your head around. And that's why everything that we've done here is really, we kind of qualify it by saying the limit is 1, right? Which kind of means it, for all intents and purposes, isn't that decimal 1 for practical purposes, right? Because it'd be 0 point, infinite number of zeros and a 1. Do you know things like that freaked the Greeks out, something scary? And they just said, forget it, this is stupid, right? I mean, they didn't like the frog jumping. Can you see the problem they'd have with this one? Right? So what is left? Oh, very good timing. A couple of questions. I want to show you these ones because they're easier to show you than they are to say. And here's the first one. It's dead easy to answer this question because there's only 2 choices, and the choices are yes and no. And if you get it wrong, since you get 5 guesses, you're going to get it right the second time. So you are not allowed to guess. You must give me a good reason why it's yes or a good reason why it's no. So you have 2 different series and they both diverge. Is it guaranteed that if you do a series that's made by joining them together, that will necessarily also have to diverge? What's the answer? You're a lot of going to guess, aren't you?
So no. Would they converge to the average of those two?
Oh, interesting. The answer is no. So you got it right for that. I'm not saying that your description of why is kind of wrong, because it's maybe a little bit vague for me. It's not vague, it's just for my brain. Here's an example of why it might not happen, right? A lot of the times it will, but can you imagine one of the series was sigma n and the other series was sigma negative n? If you've joined them together, wouldn't you just get sigma 0, which is a whole load of zeros being added? Wouldn't that be an example of two divergent series, right? But together, they work. In fact, couldn't you do that for anything? Find a divergent series, right? And then the other one, just stick a negative in front of it. Wouldn't it also be divergent? When you stick them together, won't they always kill each other off? So you get 0. So I'm not saying that's the only explanation. I'm not quite sure what your average meant. So you might have been saying what I was saying, but just in your own way.
Yeah, that's kind of what I meant. I didn't know if that was the right word to use, but yeah.
Okay, makes sense. Right, now, there are a couple of, are we done with this? I think we are, let me check. Just make sure I didn't miss anything, because I was pretty quick in some places. I think we're done. Oh, am I good or am I good? Look at the time. I should get bonus points. When you see my boss, tell them I should get a 20% raise because I'm so good at time management, right?
Just 20?
Well, you could add an extra if you think, but I don't want to push it, you know? You might get 20 when you wouldn't get 25. Isn't that part of the negotiation process? Okay, put your last names down, everybody. Make sure it's only your last name, and because I use it for registration. The test is up and running, so if you need to do the test early, which I know one, if not two people need to do it, it is live. You should be able to see it. Tell me if you can't, and I'll make sure it's live. But the rest of you, you've got until midnight Sunday to do your 2 sections of homework and online test 1.